Oh, okay. So this is going to be just some review on solving equations and inequalities. Try to go through this pretty quickly. Hopefully it'll take me about 15 minutes. So solving like something like number one is a basic like two-step equation. First thing you want to do, our goal, period, for any equation is to get the variable alone. So we want to get this 5x by itself because again, essentially what we want is something that's just like x equals 5, x equals negative 3. So to work towards that, we want to get the variable by itself. The first thing we want to do here, therefore, is to get rid of this 3. How do we get rid of the 3? Since it's a plus 3, we minus 3 because that's the opposite operation of adding 3. And 3 minus 3 is 0, so that's why we're allowed to cancel that out. That's why we pick it. So we're left with the 5x equals 20. Give me a little bit of time to work my handwriting out again with this writing on the screen. Then the next thing I want to do is I don't want 5x, I want x. So in order to get x, or 1x, we want to divide by the 5. This is multiplication. We do the opposite, which is to divide. Again, we always do inverse operations. So we end up with x is 4. Hopefully that was pretty straightforward for number one. Again, that's pretty much as easy as it'll get when it comes to solving our equations. Moving on to number two. Two is a little harder because it has an extra step we have to distribute first. So make sure what you're distributing is a negative 3. So we do negative 3 times 2x. That's going to give us a negative 6x. Then we have a negative 3 times a negative 8. That's going to be a plus 24. A negative times a negative is a positive. And then we get the negative 12. All right, so now moving on. Next step is going to be now we're basically at a problem that looked like number one, where it's a two-step. So we want to move this 24 because we want the variable alone. So I'm going to do a minus 24 because it's a positive 24. So I do the opposite. Again, 24 minus 24 is 0. That's why we cancel it out like that. We now have a negative 6x. Again, make sure you bring the sign down. Equals, these are both negatives, so it's going to be a negative 36. Again, that's another issue that a lot of students have. They'll put 12 for that. You got to watch your sign numbers. In this case, a way to think about it is like you owe me $12 right now, and then you ask me for another $24. So now you're going to owe me more money. So it's going to go up, but it's still a negative, but you're in the hole even more. And now we're going to divide by a negative 6. And we end up with x equals 6. Again, a negative divided by a negative is a positive. All right, keeping it moving. Something like numbers 3 and 4, these are also examples of multi-steps because we have to combine like terms. For number 3, we want to combine the 3x and the 2x. We can only combine things that are either both constants or both variables, etc. We can't combine like something with a variable with a number or with a constant. So we end up with 5x plus 6 equals a negative 15. Now, sometimes here, this is where we run into some issues. Some students will think that they can combine the 6 and the negative 15. The 6 and the negative 15 are on opposite sides of the equation. So if we go back, if you tried to do that, that would be like us combining the 3 and the 23 for number 1. As long as they're on different sides of the equations, the only way to move, to get it to go to the other side or get it to cancel, is to actually go through the process of either subtracting it or adding it to cancel it out. So you could not just do these two together. You have to do a minus 6, a minus 6. All right, so we end up with 5x equals negative 21. We divide it by 5. We end up with x equals. You can leave it as a fraction, so you could leave it like that. If you prefer decimals, it's going to be negative 4.2. Both are fine. Number 4 is another one where we have like terms to combine, but we have two pairs of like terms here. I'll denote it with a color. We have the x's that can be combined. Again, you always want to take the sign with it. So it's 4 minus 7. So that's going to give you a negative 3x. And then we also have constants, which are numbers with no variables. That's what a constant is. So we have 6 and 9. 6 and 9 come together to give us 15. All right, so this is what we have. Then once we get to this point, now we're back to the two-step equation. Minus the 15. We end up with 3x. That's really crooked. 3x equals negative 3x. Remember to take the sign down. Equals, sorry, I'm just going to move this down. I hate when I'm not really lined up. Chances out. So it's going to be negative 3x equals 3. Divide by a negative 3. We get x equals negative 1. All right, moving down. Numbers 6 and 5 both have variables on both sides. So this will be the first one we've looked at like that. I'll do 6 first because 6 is actually a little easier than 5. And then we'll do 5 because 5 has like some distributing and variables on both sides. 6 doesn't have both of those things. So for 6, in this situation, this is the first one where we have variables on both sides. It would be incorrect to approach number 6 as we approach numbers 4 and 5. I'm sorry, 4 and 3. Again, if we look back, 4 and 3, or 3 and 4, with those, we only combine variables if they were on the same side of the equal sign. So if your thought is that we can do 2x plus 5x and say 7x, that is incorrect. The only way to move it when it's on one side versus the other side of the equation is to do the actual subtraction or addition. And in this case, we're going to subtract the 2x. You can choose to move the 5x or the 2x. As a rule of thumb, we math teachers tend to tell students to move the smaller one. The reason we say that is because if you move the smaller one, you can try to avoid negatives sometimes, so that's the benefit of that. We end up with 7 equals, this is 3x plus 16. And now we want to move the 16, so minus 16 because it's a positive. That is just negative 9 equals 3x. Divide. We get x equals negative 3. All right. So I'm going to give you guys a second to try to do number 5 on your own. There's some distributing and then there's variables on both sides. Let's see if you guys can try it and then you can catch up to me. So pause the video and give it a try. All right. So hopefully you guys are able to distribute and get to this point. Once you've gotten to this point, this problem is, like I said, much harder than 6. You still have to do something else. So we did the distributing. Now we still have to go through the process of combining the like terms. But again, key thing to remember is that the like terms are only on the same side. So we're going to do the 4 and the 6x, giving us 10x, minus 2 on this side. And on the other side, we can combine the 16x minus the 10. So that's going to be 6x minus 50. All right. So now we're back to a problem where we have variables on both sides and we can just go for it like we did number 6. So for this, again, I suggest that you move the one with the smaller coefficient. So we have a 10x, we have a 6x. I'm going to move the 6x. Cancels out. We end up with 4x minus 2 equals negative 50. Now just to again clarify why I chose to move the 6 versus the 10. If I move the 10x, I'm going to have over here 6x minus 10, which would mean I would have a negative 4x. And that's traditionally where students have more mistakes and issues, is when they have negative. So if you can avoid a negative, avoid it. All right. Now our next step is to get rid of this 2. I'm going to do a plus 2. I end up with 4x equals negative 48. Divide. I get x equals negative 12. All right. Next couple problems are the inequalities. Now, inequalities, we do pretty much the same as equations. There's just going to be a few little nuances. The first thing is going to be that you're going to have to graph it on a number line. That's the first big thing. And then the other thing is whenever you multiply, this is the asterisk, it's going to change it. Whenever we multiply or divide by a negative, hopefully this sounds familiar to you guys, we must flip the sign, we must flip the inequality. We must flip the inequality. So, by that, what we mean by flipping the inequality is that if it was less than, if we divide by a negative, it's going to become greater than.